In this video, we're going to learn how to find trigonometric function values for various angles using the unit circle. Here's the unit circle that we already labeled with angle measures for all angles related to three special ones. And we labeled all points that lie on the terminal sides of those angles. We learned that coordinates of these points have a special meaning. And that is that the x-coordinate of any point on the unit circle represents cosine of the corresponding angle, and the y-coordinate represents sine of that angle. And that's what we're going to use to find the trigonometric function values for the given three angles. So let's start with cosine of 240-degree angle. We begin by locating that angle in the unit circle. And 240 degrees, it's the angle that's already labeled. What we'll do next, we'll look at the coordinates of the point that sits on the terminal side of this angle. And since we need to find cosine, we have to look at the x-coordinate of that point. So the x-coordinate is here, -1/2. And it represents cosine of that angle. And this is how quick we get the answers. So cosine of 240-degree angle is -1/2. Let's try the next one. It's sine of -135-degree angle. Again, I'm going to start by locating the terminal side of this angle. Pay attention to that negative sign. It means that I will be sweeping that angle clockwise. So I start here, it's -90, and I have to sweep another 45 degrees. So that's where the angle will terminate. Next, I'm going to look at the coordinates of the point that sits on the terminal side of that angle. And here are the coordinates. -radical 2/2, -radical 2/2. While they happen to be the same, I still want to talk about which one I should technically pick. Since we need to find sine, we're going to be looking at the y-coordinate of that point. So sine is represented by the y-coordinate. So that's where I'll get the answer from. Sine of -135-degree angle is -radical 2/2. And the last question on this page is cosine of 480-degree angle. It's a positive angle, so I will be sweeping counterclockwise. I need to find where this angle terminates, 480 degrees. So I'll start 90, 180, 270, 360. I have to continue. And how much further do I need to go? I can quickly calculate that. So if I take 480 and subtract 360, I'll get 0 to 1. I'll get 120. So I need to go 120 degrees more. So that means that I will sweep this far. And that is where 480-degree angle terminates. So it terminates at the same place where 120-degree angle terminates. And both of them, and many other angles that terminate at the same spot, will have cosine and sine values represented by those two coordinates of the point on their terminal side. Now, in my case, I need to find cosine, and cosine is the x-coordinate, which means that I will be looking at this value here. That's what cosine of 480-degree angle equals to. It's -1/2. So that's how you find cosine and sine values. You determine where the given angle terminates, you look at the corresponding point, and you choose the correct coordinate, either the x-coordinate for cosine or the y-coordinate for sine value. But how about the other functions, such as tangent and the reciprocal functions? Let's look at some of those examples as well. But here we need to find secant of -210-degree angle. And we have two different ways to obtain the answer. For both methods, you also start by locating the terminal side of that angle. Since I'm given the negative angle, I will be sweeping clockwise. That's -90, -180, and I need to go 30 more, right? Here it is. That's where -210-degree angle terminates. Right away, we can see the coordinates of the point that sits on the terminal side of our angle, but remember that those coordinates represent cosine and sine, but we need secant. Well, but what is the secant? Secant is the reciprocal of cosine. right? And that means that, well, knowing cosine, I can find secant. And that's going to be method number 1. So we know that secant is the reciprocal of cosine, and since cosine of negative 210 degree angle equals to, remember cosine is the first coordinate, so I'll have to pick negative radical 3 over 2. So negative radical 3 over 2, that's cosine. To find secant, I simply have to take the reciprocal of that number. So then secant will be negative 2 over radical 3. And of course this fraction has to be rationalized, so I'm going to multiply by radical 3 on the bottom and radical 3 on the top. So that gives me negative 2 radical 3 over 3. And that will be the answer. But there's also one additional method. And the second method will allow us to avoid this kind of calculations and chance of making a mistake, maybe when we perform this kind of arithmetic. So for the second method, we're going to use the reference angle. So what is the reference angle of the angle that measures negative 210 degrees? Remember, the reference angle is the one for which one side is the terminal side of the given angle, and the other side is always the x-axis, and the reference angle has to be acute. So that must be this angle here, theta prime. And as you can see, the measure of theta prime is 30 degrees. And we already observed by looking at the coordinates of those points around the unit circle that all related angles around the unit circle have cosine and sine values with similar numerical parts, and the difference is just the signs, depending on which quadrant. Depending on the quadrant in which angle terminates, numbers change from positive to negative. Well, this is true not for only cosine and sine values for all related angles, but for other function values as well. So what I'm trying to say here is that secant of negative 210 degree angle will have exactly the same numerical part as secant of the 30 degree angle. And then we'll just have to think about what's the appropriate sign to use, positive or negative. Let me write this all down. So first I'm going to say that I found the angle theta prime, reference angle, and it's 30 degrees. And I want to write down what secant of 30 degree angle is. And we can easily get this information from the table of trig function values for the special angles. Here's 30 degree angle, and I need to find its secant value. So I go down this table, and that's where I'm going to obtain the number. So it's 2 radical 3 over 3. That means that secant of the given angle will have exactly the same numerical part, and the only thing I need to consider at the end, whether it's going to be a positive value or a negative value. For that, I remind myself that my angle terminates in the second quadrant, and secant is negative in the second quadrant, well, since it's reciprocal of cosine. So that means that I will place negative sign in the front, and I'll just make a note for myself that I placed that sign because of the second quadrant. Okay, and that's how I obtained the answer. As you can see, there are no calculations involved with this method. And if you're wondering which method is better to use, method 1 or method 2, I'm going to tell you it's up to you to decide. Whatever method makes more sense to you and you find it easier, you can go ahead and use it. For our last example, we need to find cotangent of 660 degree angle. We're going to start by locating where that angle terminates. Obviously 660 is more than 360, so I definitely have to go one full circle. And to find out how much more I need to sweep, I will subtract 360, that's how far I already went. So it's 0, 0, 3. Okay, so I need to go 300 degrees more. And that means that my angle will terminate over here. As with the previous example, I'm going to show you two different methods of getting the answer. For the first method, we use the definition of the given function. Remember that cotangent of an angle is defined as x over y. Well, it's reciprocal of tangent, which is y over x. Now, what are those x and y? They are coordinates of the point that sits on the terminal side of our angle. So that means that For the first method, we literally have to take the x-coordinate of the point and divide it by the y-coordinate of the point. So cotangent of 660-degree angle will be 1/2 divided by negative radical 3/2. This is a complex fraction divided by a fraction. To simplify it, we're going to change division operation, which is the fraction bar, to multiplication by the reciprocal. So to simplify this complex fraction, we're going to take 1/2 and we will multiply by the reciprocal of the denominator, so it's still negative, but as I flip it, it's going to be 2/3. We're multiplying fractions across, but before we multiply, it's always convenient to simplify them as much as we can, so I can see that 2's can be divided out. And as I multiply across, I'll get, first of all, negative result overall, and it's going to be 1/3. And of course, to rationalize, I will multiply by radical 3 on the top and on the bottom, and that will give me negative radical 3/3. So that's what cotangent of 660-degree angle equals to. That was method 1. As you can see, it's based on the definition of the function, and it involves some arithmetic. Let's look at method 2. With this method, you don't have to do any computations. Method 2 is based on the reference angle. What is the reference angle in this case? Reference angle is always between the terminal side of the given angle and the x-axis, and it always has to be acute, less than 90. That means that the reference angle is here, that is theta prime. What is the measure of the reference angle? Well, from 300 to 360, it's 60 degrees. And as we said, function value for our original angle, meaning that cotangent of 660-degree angle, will have exactly the same numerical part as the cotangent of 60-degree angle, as the reference angle. So again, I'm going to refer to the table of trig function values to find cotangent of 60-degree angle. Here's 60-degree angle, that's this column with all the values, and I need cotangent. Cotangent is right here, radical 3/3. Tangent of 60-degree angle is radical 3/3. And right away, I can say that cotangent of my angle, 660, will have exactly the same numerical part. But I need to make sure to verify the sign. Is it going to be a positive value or a negative value? For that, I go back to the unit circle to remind myself that angle terminates in the 4th quadrant. And what we can say about sign of cotangent for angles that terminate in quadrant 4. Since cotangent of an angle is defined as x/y, and in quadrant 4, x and y coordinates have different signs. X is always positive, y is always negative. Cotangent is going to be negative. And that's why I'm going to place negative sign in front of the number I just wrote. And I'll make a note that I place that sign because angle terminates in quadrant 4. Okay, so that's our answer, and of course it's exactly the same as the answer we got using method 1, because no matter what method we use, we should get the same result every time. So from the example that we just tried, we can see that finding sine and cosine of any angle related to a special angle is very quick and easy using the unit circle. Finding other function values are also not that hard. In fact, you have 2 different methods to choose from. And for that, you just have to do some computations. That's method 1. Or, in addition to the unit circle, you would need to use the table of trigonometric function values.